Today's section of material is called Quadratic Equations. Bits and pieces of this we've already encountered, so you're going to be like, oh yeah, we already did that, and you're right. But we're going to kind of be looking at it from a more holistic point of view and going a little further in depth today, all right? So the first couple you're going to have seen. We've done these kinds of problems before. So example number 1 says that we're going to solve 2 minus v times 5v minus 1, and that's already equal to 0. And when we saw this before, I talked about something called a zero product principle. And the zero product principle said that if you have a times b equals 0, then it must have been true that one of them equaled 0 to begin with. And that's what we have here. We have two different pieces that equal 0 when they're multiplied. So they have to, one of them at least, be equal to 0 to start with. So what we do is we set each piece equal to 0 and solve it for two potential answers to our problem. So on the first one, what would v equal? Can you just eyeball it and tell me on the first one, 2v minus 0? And 2v equals 0? 2 minus v, I can't even say it, 2 minus v equals 0. What's v? It's 2. Right? 2 minus 2 equals 0, so v is 2. On the second one, you might not know it right off the top because there are two steps to this particular process. But if I add the 1 and then I divide by 5, my second value for v is 1/5. Okay. Guys, shake your head if you remember us doing this. Yeah? Okay, good. Hasn't been that long, but it has been probably at least 2 weeks. The second one is not set up the same way. What looks different about the second one than the first one? There's a squared in it. What else? It's not already in factored form, which is why there's a squared in it. Yeah, it's not already in factored form. So we first, on this one, actually have to factor, and when we are looking at any factoring, to start with, we should always ask, does any of it have something in common with everything? And on this one, it does. So what is in common to both terms on this particular problem? 4x. So we'll factor out a 4x from each part. So if I take 4x squared and I take out a 4x, what am I left with? Yeah, x, and then the 24x would be plus the 6. And actually, once it gets into that step, it is in the same form as the first one that we did, where we set each part equal to 0. So if 4x equals 0 and x plus 6 equals 0. Okay, on the first one, what does x equal? 0, right? I divide by 4, and so x is 0. On the second one, what does x equal? -6, right? Because I can subtract the 6 to give me a -6. So there are, again, two answers. But maybe you don't have a binomial. This is a binomial, 2 terms. Maybe you have a trinomial like number 3. What would I have to do on number 3? Yeah, I'd still have to factor, right? But I don't have something in common to everything on this one, do I? No, I don't have a common factor to all 3 terms on this one. I could have, but I just don't. So I'll set up my parentheses. It's v squared at the beginning, so these are each v. What does this sign here tell me that my signs in the middle are going to be? The same. And then they're going to be negative because this one's a negative, right? So they're both going to be negative. So now I need 2 numbers that multiply to 21 and add to 10. 3 and 7 will do it. Okay, double check. -3v, -7v. Does that equal -10v? Yeah, it does. Good job. And then, again, now it's actually in the same form as problem numbers 1 and eventually problem number 2 got to, where I set each part equal to 0. So v minus 3 equals 0. V minus 7 equals 0. So what is v on the first one? It's 3. And on the second one, it's 7. How is 4 different than 3? Okay, it has a number in front of the x squared. It's going to make things a little bit more challenging. What else do you notice? What you have, Trey? It's not equal to 0. And that's actually a really big problem. Please don't be led astray just because it starts out like this. It has to be equal to 0 to continue this problem. So the first thing you're going to have to do is move it all to the same side. All right? Anytime you have a squared term or a cubed term or something like that, you've got to get it set equal to 0 before you can do anything else. So the first thing we're going to do is we're going to make the 5x on the right become a positive 5x on the left, and the negative 3 on the right become a positive 3 on the left. I'm going to move them or add them to the other side. Is everybody good with that? All right, cool. So if we're thinking trial and error, I think Devin was the one who said that there's a 2. Was that who said there was a 2? Keeley did. Somebody told me there was a 2 in front of the x squared term, right? And so that makes it more difficult to do the factoring because I'm going to have a 2x and an x here. What about my signs? They're both positive. All the signs in the problem itself were positive, right? All right, I'm going to have a 3 and a 1. I just have to figure out where they go. So if I put a 1 here, oops, a 1 here and a 3 here, will that work? Okay, why not, Lauren? Yeah, that would be 7, right? In the middle I have 1, on the outside I have 6, that's 7. I don't want 7, I want 5. So it must be that I need to switch them, right? So let's check. Does that give me 5 in the middle? It does. So this is the actual ordering that I want. And then I can set each part equal to 0 to solve. On the first half, if I subtract 3, I have 2x equal to negative 3. I divide, then x is negative 3 halves. What about over here on the second one? X plus 1 equals 0. Yeah, x is equal to negative 1. Did not get there, right? There we go. Okay, everybody good? All right, I don't really think I've shown you anything you haven't seen before. I mean, we haven't talked about all of this in super detail, but we've touched on all these ideas. This one's something that we haven't seen like this before. So let's go through this one. What you should notice on this one is we have something in factored form. Like, that's great, except that we also have some stuff that's not in factored form. So I don't have factored form equal to 0 or factored form equal to a constant. I have factored form equal to something else with variables in it, right? So in order to do this problem, it still has to change and to look like problem number 3. I have to unfactor everything, distribute it all out, combine things that can be combined, put them all on one side, set equal to 0. So even though it looks like it's sort of helpful in the sense that it's factored, it really isn't, because not all of it's factored. So on the left-hand side to begin with, I actually need to write out what I've got. So I've got x minus 6 times x minus 6. Please remember that is not x squared minus 6 squared. You have to actually distribute out. So x times x is x squared. X times negative 6 would be negative 6x. And then negative 6 times x would be negative 6x. And negative 6 times negative 6 would be 36. All right, what would you like to do next? Yeah, probably combine the 6x's would be nice. So x squared minus 12x plus 36 is equal to 2x squared minus 21x plus 56. Then what? Okay, we can subtract 36. Could we subtract some other stuff? We could actually do it all in one step if you want. We need everything to be on the same side, right? Which side do you want to move it to? Do you want to move it to the right side or do you want to move it to the left side? Probably the right side. My coefficient for x squared will be positive if I move it to the right side, so that's kind of friendly. So if I do minus x squared on the left, I'll do minus x squared on the right. I can actually do plus 12x on the left and plus 12x on the right, and minus 36 on the left, which is the one Lauren noticed, and minus 36 on the right. And if I do that, what am I left with on the left? 0. Okay, what am I going to have now on the right then? X squared minus 9x plus 20. It actually cleans up super nice. That's very friendly. Nice, so I can factor this. It's a coefficient of 1 at the beginning, so I have x and x. What are my signs going to be? A negative and a positive, right? I didn't say that right. A negative and a negative. There we go. I need two of the same signs because it's a positive at the end. And then the signs need to both be negative because it's a negative in the middle. So, we need two numbers that multiply to give me 20 and add to give me 9. 4 and 5 is it? Hannah, good. I'll set each part equal to 0. And what will x equal in each case? Positive 4 and positive 5. Okay. There's a couple of ways we could do number 6. On number 6, we could distribute it out like I did in the last problem. We could do that. Wouldn't hurt anything at all. Absolutely be just fine. However, on this one, there is a simpler way to do the problem. Over here we had the issue that the other pieces that were not in factored form had some variables in them, right? But that doesn't happen on this one, yeah? The piece that's not in factored form, the 16, is just a number. So one other option on this one, and again, factor it out if you want to, or distribute it out if you want to, but on this one we could move the 16 to the other side because it's a constant. And then how would I work to get the solution from here? Right, we've seen this happen before. We can take the square root of both sides. And that leaves me with x plus 6 on the left. Now when we put a square root into the problem, what goes along with it? Plus or minus, good. And what is the square root of 16? It's 4. So what this really means is that the x plus 6 could equal 4, or the x plus 6 could equal negative 4. And from here, I can solve each piece. So on the first one, x would be negative 2. And on the second one, x would be negative 10. I wanted to do that problem in this way because it actually leads to one other method that we have not talked about for solving quadratic equations. And that method has to do with something called perfect square trinomials, which we have talked about. So just as a reminder, a perfect square trinomial means that you have a plus b, or it could be a minus b, okay, but so this really could say a plus or minus here, and this can say plus or minus here, squared. And when you distribute it out, it actually becomes a squared plus or minus 2ab plus b squared. And at the point when we saw this before, we saw it in the point for factoring, and I commented to you that for factoring purposes, it's really kind of irrelevant. It doesn't really help you at all. But it comes back up again here. So what we want to be able to do is we want to be able to take this form right here, or actually even a reduced form of it like this, and find the value we would need to add at the end so that it becomes something that can be perfectly squared. Okay? So what we're going to do is we're going to start with something that looks like this. We're going to add something on, and we're going to turn it into something that looks like this. And then once we do, we're going to be able to solve it in this fashion, where we take square roots, pluses or minuses, and then add things on. So let's take a look at what I mean by that. We're going to start with, oops, there's an x missing. That should say x squared minus 18x. We're going to start with a binomial, x squared like this, x squared minus 18x. And we're going to try and figure out what needs to go right here to make it be able to be perfectly squared. Okay? And the way that you do that is this. So this is one of those pattern kind of things. You take the linear term, linear means the term multiplied by x, I should say linear coefficient. I just want the number. So in our case, this is negative 18. You divide by 2. And you square it. That's always the way that it works. So what is negative 18 divided by 2? It's 9, negative 9. And what is negative 9 squared? Positive 81, you bet. So on this one, the value that goes in the blank, if you will, is an 81. And if we go through to factor it, what I want you to see is that here's the x's. And then I would be looking for two numbers that multiply to 81 and add to negative 18. Well, they're both negative. What are the two numbers that multiply to 81 and add to 18? They're 9. In particular, they're exactly the value that I had before I squared. Not only that, but they match, which means that this could be now written perfectly as x minus 9 squared. Now, for the purposes of this problem, we weren't asked to do any of this over here. Okay, that's not part of this problem. But that's the reason we wanted to add the 81, is to turn it into something that was able to be perfectly squared, written as a perfect square. Okay, that's why we did what we did. So using this idea of finding that extra plus whatever at the end to make it a perfect square, and the square root principle that we had from example 6 above, we're going to do a process to solve that's called completing the square. Okay, so we're going to do a couple of examples because this is a topic that's new for us. What I want you to see on this is that there is a value here, right? There is one. Usually it's not the one we want it to be. So our first step is to simply move that to the other side because it's not part of our process yet. So I've got the x squared plus 16x. Please leave a space, and then we will put the minus 59 or negative 59 on the right. Okay, so good. So far, so good? Nice. So we need to figure out what needs to be added right here. What am I going to put in that blank to make this work? Well, I'm going to put in the number that is this value divided by 2 squared. So what is 16 divided by 2 squared? It's 64, right? 16 divided by 2 is 8. 8 squared is 64. But I'm working with equations, and you can't just add 64 to a side of the equation. If you add it on one side, you got to add it on the other side as well. Okay, does that make sense to everyone? Add it on one side, you'd be adding it on the other side as well. Very good. So, the reason we did that is because now this will factor perfectly as something squared. It's the x at the beginning. They're all addition signs, so it's a positive. What's the value that will go in this blank spot after the plus sign? It's an 8, because 8 times 8 is 64. What do I have on the right-hand side? I have 5. And now the problem actually looks like this one, right? This was x plus 6 squared equals 16. I have x plus 8 squared equals 5. So what would my next step be? It would be to square root. You're right. So what is square root of x plus 8 squared? It's x plus 8. And then the square root of 5 part would become, yeah, plus or minus the square root of 5. And what would our last step be? Subtract the 8. So let me remind you, because we saw this happen before, it makes it a lot easier to keep these distinguishably different if I put the minus 8 at the beginning and the plus or minus between them. So it looks like this. If you choose to write it like this, you need to be really, really, really careful that it doesn't look like that minus 8 shows up underneath the radical. Okay? So this is a cleaner way to write that. Okay, let's try another one. Completing the square, same process. So, comparing it to what we just did, what was the first thing that we needed to do? Subtract the 2, very good. So I'm going to rewrite this as x squared plus 6x and leave a blank spot and put the minus 2 or the negative 2 on the right. What's next? Right, it's taking this value, dividing by 2, and squaring. So what is 6 divided by 2 squared? It's 9. Now what? Oh, good job. I thought you might forget to. Good job. We got to add 9 to the other side as well. Yes, we do. Okay, now what? We will in just a second. We need one more step before that. Do you know what it is, Sarah? Okay, so factoring. That's what you're trying to describe. We have to factor it, and it factors as a perfect square. So you're right, it's going to be x plus 3. X because that's going to give you the square root of the x squared part, and 3 because that's the square root of the 9 part. And it's positive because the signs are all positive. What's on the right-hand side? 7. And then Sarah already holds our next step too, which was to take the square root. Yeah. So now I have x plus 3 on the left. What do I have on the right? Good. Plus or minus square root of 7. Last step. Subtract the 3. So we end up with x equals what? Yeah, sorry, I left my negative off. Negative 3 plus or minus square root of 7. Okay, any questions on that? Okay, one more thing I want to show you, and then we'll pause for today on this lesson. We've seen this before. This is not new information, the quadratic formula. But the quadratic formula is, again, another way of solving quadratic equations, so that's why it's showing back up here. So just a reminder what it looks like. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what we're going to do when we come back next time is we're going to take the same equation that we had on number 9, and we're going to solve it with the quadratic formula, and we're going to call that number 10, and show that we get the same answer either way. Okay? I have a little bit more beyond that in this section, so what we're going to do, everybody's here today, and so I didn't send around the sign-in sheet because I left it at home with a stack of other stuff, and I told you it's a forgetful kind of day. We're really only about 2/3 way done with this lesson, so I'm not even going to worry about the fact that I don't have the homework sheets with me. I'll bring them next time, and we'll go from there, okay?